Hello everyone, and welcome to your first screencast of the year. We're going to be covering Chapter 1, Sections 4, 5, and 6, which is going to be talking about solving absolute value equations, solving inequalities, solving compound and absolute value inequalities, and also a little bit of writing absolute value equations thrown in there, which is likely something that is new. So, first let's review what absolute value is. The absolute value of a number is the distance from zero. And since distances cannot be negative, such as I would never say, oh yeah, I'm negative 5 miles away from that point, always must be positive when we are talking about the absolute value of a number. So the absolute value of, say, negative 5 is 5, but the absolute value of 5 is also 5, because we're just talking about how far away it is from 0. So if we look at a problem, a standard adult tennis racket has a 100 square inch head, plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. So it told us that we're going to be using that absolute value equation, but otherwise, without any sort of really complex equations, or at least multiple equations, we wouldn't be able to solve this for ourselves. Now, obviously, you can tell, okay, I know what the two answers are going to be, but in some cases, these situations can be very complex. However, the way you set them up will always be the same. You're going to have your central value, like the ideal, sometimes I like to call it, and then your range. How much plus or minus can we go with that number? So in this one's case, we have our absolute value bars, x minus something. So our central value, or our ideal, is that 100. So I'm going to put x minus 100. In our range, we can go up or down 20 square inches. I have my equation. Now, as it asks for, I'm going to solve it. And remember, with absolute value equations, the way we want to set it up, for one of the equation situations, we're just going to pretty much just drop those absolute value bars. For the other one, we're going to drop the absolute value bars and then make your one side negative. I prefer to make my one side negative that just has the least going on, especially no negative x, but if you've been taught the other way and it's always worked for you, then you can go ahead and do that as well. So I've got two equations to represent my high end and my low end. I'm going to do the same thing to both sides, to both equations. So I get x equals 120 and x equals 80. So my range is 80. There's no reason that it can't be equal to, so it's less than or equal to. Let's go with x is less than or equal to 120. So that's our range. Like I said, probably just from looking at that, you'll be like, well, obviously it's going to be 80 and 120. But again, sometimes the situations they give you, the equations are a little bit different, or it's very obscure, the range situation. So just write out your equation. I'm going to be looking for that anyway, so now you know how to do it. Solving an inequality. Same rules as equations, just the only thing you have to watch out for is if you multiply or divide by a negative number. It doesn't matter if you add or subtract a negative number, that's all fair. The only thing is that multiplication and division. So I've got negative w over 4 is less than or equal to negative 7. I have two choices. I can multiply by the 4 and then divide by the negative 1, or I can just go ahead and multiply both sides by negative 4. Because I multiplied by a negative number, I'm going to make sure I flip this inequality, making sure if it was an or equal to, it stays an or equal to. So we are going to have our w by itself now. Now we are greater than or equal to negative 7 times negative 4 is positive 28. We have our answer. It also says to graph. So just a simple little graph. Close circle because we are or equal to. And since we are greater than, and there we are. Compound inequalities consist of two inequalities that are joined by the word or the word and. And they're usually joined by symbols more so than words. So kind of like what we did with that inequality above, we can add the same numbers to each side, subtract the same numbers by each side. Multiplication and division, you just have to be careful if we're talking about negative numbers. You can multiply and divide by any positive number and not have to do anything. It's just when you work with those negative numbers that you have to be careful. So just watch out for that. If you are a total fan of memorizing, go for it. Memorize all these inequalities and their equivalent forms and the graph of the solutions. Way I like to think of it though, if I have we'll start with the greater than. I like to think of that as greater than. Which then leaves less than, which is somewhat silly, but if you remember that greater than, you'll have your or situation where you're facing the outsides, and you're set. Only thing you sometimes have to worry about these is if you are supposed to have a less than, so and together, but your solution set faces the outside, then you have no solution. So that's sometimes what you have to just kind of double check for yourself. Okay, should I have a union or an intersection? This would be an intersection, what they have in common. This one would be a union. Everything from each of them. So just watch out for that. So let's just solve one together and then we'll wrap it up. We have absolute value equation. I see a less than. It's not greater than, so I should have an and situation. Always at least make that mental note to yourself so you know what your solution set should look like. Set up your two equations. For your other one, since you're multiplying your other side by -1, make sure you flip your inequality symbol. Okay. Solve both of them. Subtract through here as well. So I have t is less than or equal to 1/8, and t is greater than or equal to -7/8. So if I draw that for myself to make sure that there's not a no solution situation, I've got 1/8 here, -7/8 here. I want to go this direction for the 7/8, -7/8, and this direction for the 1/8. So it's everything in here with closed circles on each of these. Some of you may have learned to bracket it off if it's a closed circle and use parentheses if it's an open circle. Even if you haven't learned it, if you would like to use it, that's totally fine too. Whatever you feel comfortable with. So now that you're done with this, In class, we'll be able to do some activities and practice problems working with these types of situations. So I'll see you then.